folks. Robert Starmer bringing you another episode of Cumulus on Cloud. Today we're going to talk about using Kubectl, or rather, should you? So one of the more interesting sort of conversations that I think is coming out of the new sort of no ops is the answer to all ops conversation is this prospect that people should not, or rather developers, let's be specific as to which people, developers should not be using Kubectl. I've seen this now in a couple of conference proceedings as sessions that have been presented, and I'm even seeing it sort of percolate around the web on Twitter and some of the other services. And I think it's an interesting question. And having looked just recently at building an application, actually we've got a little team that's been building one, I'm starting to see some of the value of this concept. So let's just step back real quick and think about how a developer might develop an application today and how they're going to, at least initially, expect to use a tool like Kubectl or really any of the command line operations tools of that environment. Now, we built a Ruby on Rails application. It has a MySQL database, and we containerized all those resources. We are using currently generic upstream MySQL database container model, so we don't have to actually build that container, but we do have to build the container for our application. We're starting with a Ruby application engine as our start point. We're using the bundler engine to actually pull all of our resources together. So all of these are fairly standard processes within the Ruby world, especially as you take a Ruby application and containerize it. We're of course managing our code in Git, so it's doing a lot of the heavy lifting of doing some integration testing, actually kicking off the artifact build, so our developer doesn't actually go and build a Docker image themselves. They actually have the Git engine handle all of that for us. So all these pieces all make sense. They're fairly standard. When we actually were looking at then taking that and moving that into an operational space, the first thing we did was to start crafting manifests for our application, for the services, for the configuration files, the config maps that we wanted to map to those services, both for our database and for our application itself. This is not yet a microservices-based approach. This is just sort of the basics of any application that somebody might write today in advance of moving to microservices or function as a service type applications. Anyway, so we've been going down this path of building this application. The next thing after we started to build our manifest was that we realized that we did actually now have multiple pieces that we wanted to keep track of. So we started to build a Helm chart to support that as well, and started to realize that we're doing a lot of manipulation of the underlying infrastructure, and there was no obvious way to sort of start managing all those things together. Now, along the way came a tool called draft.sh, which is developed by the same team that actually started the initial, or actually I guess built Helm, and they're now at Microsoft, but they're continuing this process of thinking about the developer interaction with the Kubernetes environment. I think this is one of the first areas where somebody said, developers don't necessarily need to manage Docker and run Docker commands or manage the actual Kubernetes manifests and charts that are needed. Yes, there are some common architectures that can be used to sort of create automated templates for this. And you might still need to go in even after the fact and make some modifications if your application doesn't follow a standard pattern or a standard paradigm that can be implemented as a set of baseline templates. But you can also continue to extend this draft tool by creating new manifest models and chart models and calling them based on a new application template environment. So that's sort of a piece of the puzzle that we decided to actually start using to manage at least the different service components. So we still have one environment for our database and one environment for our application, but we'd like to start combining those. And that's where we think a tool like Spinnaker starts to come into play, still looking at potentially managing Helm charts, but not having Draft manage those charts for us anymore. We'd use the baseline and continue on from there. So we're starting to see a model where yes, the application developers still focus on writing Ruby, and at least today, they're not containerizing that as they're writing it yet. They are documenting the specific versions of the resources, and then they sort of treat the rest of the system much more like a platform as a service offering, where their code will get containerized by pushing it into Git. So that initial push triggers a build process, which actually builds out the container, runs all of the tests against the container. So now my container has become my artifact for unit test, for integration test, and hopefully for production deployment. And I need still a way of creating the model, the manifests, etc., and even maybe testing those manifests against a Kubernetes environment. To me, that's where currently something like Draft comes into play, by giving me a baseline template for either the application pieces in this case, or potentially if you built your own template for your application at large. If you knew how sort of all your different services need to fit together, you could potentially use Draft in that fashion to build out this system. Once we get to that point, then the only question is, how do I then take that from the development status into my operational status? And I think that there really are two different communities here. Yes, in a small company, they're all one. Everybody does all jobs. But it's really a different set of mindset or different set of thoughts that you have to have in mind as you move from the development and integration phase into the integration to production phase. And we see this in the terminology that people use. So they talk about continuous integration. That seems to sit squarely in the world of the developer. You define your code, you define the unit tests, and potentially, actually I think you kind of have to start defining the integration tests if you have multiple services that are talking together, or at least expectation that you can talk to a mocked up service API as a part of your test for your particular container. Now, I think it needs to go one step further, and we do need to actually be doing system level tests. One of the nice things about the Kubernetes environment is, of course, we have the ability to do those systems level tests and get all that value out of that environment. So again, Kubernetes looks like it's the key, but do I need to use Kubectl to talk to that environment? I might want to be able to talk to Kubectl in order to get statistics and data out of the environment to understand how it works, or I might want to talk to the Kubernetes environment via Kubectl to force a scale up or scale down to make sure that those aspects of the system are viable, especially if I expect a dynamic functionality in my environment. If I'm thinking about taking this all the way through automated delivery and into continuous deployment, then I probably also need to test roll forward and potentially, if that's the right model for your disaster recovery, roll back to a previous version. I'd like to be able to test all of those things. But again, the end user, aka developer, shouldn't be using Kubectl to do that. Instead, you should be using another tool to automate those processes and document the process of that automation in your Git repository. So you get into the model that some people are starting to call GitOps. I think this is the term coined by the Weaveworks folks, where really your operational code, be that things like Spinnaker templates, etc., and your production software code, the actual Ruby on Rails app, for example, that we were building, those pieces need to all live within a code base, a source code repository, Git being the most likely these days, and then you automate all those back-end processes. In all of this, though, I think we're starting to see that, yeah, I don't necessarily need to or even want to interact with Kubernetes directly. So as an operator, I might actually need to use Kubectl to talk to those resources, manage and manipulate how the pieces fit together. But that is not the same thing as interacting with Kubernetes as a developer. In a sense, as a developer, I need to think about how my application fits together. So I might be able to hint the system to tell it that, yes, I need to talk to certain database resources. And as we move into a full microservices-based application deployment model, I might get to the point where I no longer even need to think about how those services interact. But in the larger scheme of things, the developer really shouldn't be working with Kubectl directly. Hey, thanks for watching. If you enjoyed what you saw, don't forget to subscribe to us on YouTube. Click the little bell next to it and you'll actually get notified when we post new episodes. In fact, an even better way to get new episodes is to join us on our newsletter at kumul.us. And there you'll get not only episode notification, but you'll also learn other things about the cloud. And of course, you can always follow us on Twitter as well.